Afternoon, my YouTube viewers. It's Crystal here. In this video, what we're going to do is we're going to talk about descriptive statistics, and we're going to be talking about the three types of measurements in descriptive statistics. So the first type of measurement is going to be the measurement of central tendency. The second type of measurement is going to be the measurement of dispersion. And the third type of measurement is going to be the measurement of position. And so we're going to be talking about these three types of measurements using the R programming language. And so the first thing we're going to do is we're going to talk about the measure of central tendency. And the three main measures of central tendency are mean, median, and mode. And so we're going to create a vector in R that's going to cover this measure of central tendency. So the first thing that we're going to do is we're going to compute the statistics. So mean V becomes mean brackets V. Median V equals median brackets V. And mode V becomes S dot numeric brackets names brackets sort brackets table brackets V comma decreasing equals true brackets 1 and the square brackets 1, and that 1 indicates that it's going to be the most commonly occurring number. And then we're going to combine the values into a vector. So central values becomes C brackets, mean equals mean V, comma, median equals median V, comma, mode equals mode V. And then we're going to print the list of the central values so you can see the values of mean, median, and mode. We're going to combine into a named vector. So stats becomes brackets C. Stats becomes C brackets. Mean equals mean V, comma, median equals median V, comma, mode equals mode V. And then what we're going to do is we're going to create a bar plot to record this data. So bar plot equals bar plot bracket stats, comma, call equals C, bracket steel blue, orange, and sea green, Y limb equals C, bracket 0, max, bracket stats, times 1.1, comma, main equals mean, median, and mode of V, and Y lab equals value. So you can see our mean, median, and mode. So your mean is 14.107, your median is 6, and your mode is 50. So the mean is the average value within that vector. The median is the center value in that vector. And the mode is 50, which is the most commonly occurring value in that vector. So you can see we've got a bar plot here with your mean, your median, and your mode. So your mean is 14.107, your median is 6, and your mode is 50, and we've got a bar plot with the mean, median, and mode. So that was the first type of measurement in descriptive statistics, being the measure of central tendency. So now what we're going to do is we're going to create a bar chart with a measure of variability or dispersion, and it's going to be range, variance, and standard deviation. Okay, so we're going to be using the same vector that we used in the cell above, but we're going to compute the statistics. Range V becomes range brackets V. Var V becomes var brackets V. SDV becomes SD brackets V. So we're going to combine it into a vector. So we're going to have the dispersed values become C brackets, range equals range V, variance equals var V, standard dev equals SGD. And so we're going to print the dispersed values with print brackets, list bracket, dispersed values. And then we're going to combine them into a named vector. So stats become C brackets, range equals range V, variance equals var V, and standard dev equals SDD. So we're going to plot a bar plot of these statistical functions. So bar plot bracket stats, comma, call, that's your color, equals C brackets, steel blue, orange, and green. White limb equals C brackets 0, comma, max bracket stats times 1.1. And main equals range of variance and standard deviation of V. And Y lab is your variance. So you can see when we print off the dispersed values, range 1, that's your lowest value of range, is going to be 1, and range 2, which is your highest value of range, is going to be 50. So your variance is going to be 294.46958, and your standard deviation is going to be 17.1602. So we create a bar plot of this. So you've got your range 1 is 1, your range 2 is 50, and your variance is close to 300, and your standard deviation is 17. So you can see we've created a bar plot with the measures of dispersion being your range, variance, and standard deviation. So the next type of measure that we're going to cover is your measure of position. So that's going to be your quantile, your interquantile range, and your median. And so we're going to use the same vector that we have used in the two cells above. So we're going to compute the quartiles, median, and IQR. So QS becomes quantile brackets V, comma, probs equals C brackets 0.25, comma, 0.5, comma, 0.75. So 0.25 is quartile 1, 0.5 is quartile 2, 0.75 is quartile 3, and we didn't put 100%, but that would be quartile 4. And then so we're going to calculate the IQR, that's your entire quartile range. You can calculate the IQR yourself by taking Q3 minus Q1. And so Q3 minus Q1 is also a way that you can calculate your interquartile range, but R has a function where you can do it automatically without having to calculate it. And then med becomes your median V. We've already talked about the median. The median is the center element in the vertex, in the vector. So we're going to print quartiles, and then we're going to print the IQR, and we're going to print the median. And so basically the way it's done in R, if you want to print something that's got some strings attached to it, it has to be CAT. If you try to use the print command and there's strings attached to it, it's not going to work the way that you want it to work. So CHT is also a print function. And it's what you have to use if you have text inside the print function. So now what we're going to do is we're going to create a box plot. I decided that I wanted a box plot. So the box plot brackets V, comma, main equals box plot with quartiles, median, and IQR, comma, YLab equals values, comma, color equals light blue. And so we're going to add the horizontal lines for the Q1, the medium, and the Q3. So AB line. And so your red is going to be for your Q1. Your dark green is going to be your median. And another red is going to be Q3. And so now what we're going to do is we're going to annotate the values. So we're going to actually put text in the box plot. So you can see that your quartiles are 4, 6, and 11.5. So that's Q1 is 4, Q2 is 6, and Q3 is 11.75. And what we could do is just here, just run it again. So you can see, and then so you can see here we've added 100% into the quartiles because 1 is 100%, and so 50 is going to be your Q4. And your IQR is 7.75, and that is Q3, which is 11.75, minus Q1, which is 4, is 7.75. is your interquartile range. So it is Q3 minus Q1. And then your median is 6. Your median is your center of the vector, which is 6. So what we've done is we've created a box plot. And in this box plot, we've got Q1, which is 4, your median, which is 6, your IQR, which is 7.75, your Q3 is your 11.75, and then so your Q4 is going to be 50. But basically, so you can see that after your 11.75 or a little bit later than that, you can see that after the 11.75, you go into something called outliers. So you can see your 40 and your 50 and your 30 are values, which are elements in the vector, are actually your outliers. So that's interesting. And so this is a box plot of the vector that we've been working with in the last 3 examples. So that concludes the 3 types of the descriptive statistics, being the measures of central tendency, which is the mean, median, and mode, your measure of dispersion, which is standard deviation, variance, and median, and range, and then your measures of position, which is your quantiles, your median, and your IQR. So the next thing we have is we're going to calculate our z-scores. So z-scores are also a type of a measure of descriptive statistics. So what we're going to do is there's 2 ways that you can calculate a z-score. One way that you can calculate a z-score is to use R's scale function, which is a very easy way to do it. But the second way that you can calculate a z-score is to take the vector minus the mean and divided by the values of the vector minus the mean of the vector divided by the standard deviation of the vector. And so what we're going to do is we're going to plot two graphs. First graph we're going to plot is a plot of the actual vector. And the second graph that we're going to plot is a plot of the z-scores. So the plot is going to be plot brackets v, comma, type equals b, comma, PCH equals 19, comma, col, that's your color, equals green, comma, main equals vector v, comma, x lab, that's your label, equals index, comma, y lab, which is your y label, is your z-score. And then so we're going to plot z2, and in plot v we're plotting the vector, and then in plot z2 we're plotting the z-score. So we're going to print off, whenever we calculate the z-scores, we print them off. So you can see that these are the z-scores. That one is z1, and you can see that we've got the z-scores for z2 as well, and you can see that the values for z1 are the same as the values for z2. And so the next thing that we're going to do is we've plotted the values for vector v, and so you can see that the lowest value is 1 and the highest value is 50, and so the elements in this vector are plotted onto the graph of vector v. And now we're going to plot the z-scores. And then when we plot the z-scores, you can see that the values are a lot more compact. So the values are going to be anywhere from like -1 to +2. And so you can see that whereas the vector, the values are 1 to 50, so there's a lot more space between the values. And the z-score, the values are a lot more compact. And so what you're going to do with the scale function is, when you're using machine learning, like sometimes some of the models don't work very well if the values are not close together. And then so when you scale the values, that makes them very close together proportionally. And some of the models, it works better if the values are scaled. And so when you're doing machine learning, what you have to do is you have to run the model up without scaling and take the accuracy, and run the model up with scaling and take the accuracy. And then the method that has the highest amount of accuracy is going to be the method that you're going to use. So that concludes this video on descriptive statistics. And so the next video, I'm going to be talking about some more statistical concepts, such as inferential statistics. So I hope that you decide to watch it.